Hello and welcome. In this video, we will discuss how computers can be made to cluster data. Clustering data means grouping data which are similar into one group and making such groups out of the data. The example what we will use is regarding segmenting customers. Now, segmenting customers is a business requirement which is used by all companies and other organizations also, including governments and everybody. Now, what is done is that we have many customers and we require to identify the customers which are similar so that we could give them specific treatment. It could be for the purpose of making promotions, or it could be for the purpose of servicing customers and assigning resources accordingly, etc. One of the mechanisms used by all businesses regarding segmenting customers is using the RFM analysis. RFM stands for recency, frequency, and monetary value. So this is a very useful analysis which is done by most companies in order to segment customers. So we will see how we can utilize the machine and we can make him do clustering based on RFM. Now, RFM stands for recency, frequency, and monetary value. Recency means that how recently the customer has interacted or made a purchase or had a service call. So this is what is recency. Frequency means how frequently within a period of time the customer has been interacting with the company. It could be that how frequently the customer is purchasing some certain goods from an online store. That could be the frequency, or how frequently the customer is facing problems and is giving service calls. That is frequency. And monetary value is what is the monetary value the customer holds for the company. If it is an online business store, the monetary value would be directly what is the total value of purchases what he has made. So based on these three factors, we will try to cluster the customers or segment the customers and form groups of customers which can be given specific treatment. The data set what we will utilize is obtained from UCI machine learning repository, and the links are given here. Also, the dataset is uploaded along with a video for you to practice. Now, the data is little bit old. It is regarding transactions of an online retail store, which is happening between 2010 and 2011. However, this should be good enough for us to explain the concepts. The dataset contains about 5.5 million records, and it has about 8 fields. Now we have two data sets. One is the training data set and one is the test data set. So we will use the training data set to train our model to cluster, and then we will use the test data set to check whether the clustering is happening properly or not. One of the mechanisms what is utilized by most companies is that they cluster the data based on a training set, and then after the clustering is completed, they use the clustered data for supervised learning for further segmenting new customers when they come to the shop. Now you would understand that clustering basically is a problem which is an unsupervised learning problem, and from the unsupervised learning system what the machine produces, that we can utilize in a supervised learning scenario. Okay, now let's get on to the working of the solution. So first thing what we will do is that we will upload the libraries what is required for our example. So first library what we require is pandas. That is going to be required as we'll be dealing with data frames, and we will be making some plots. So we will use matplotlib. We will upload more libraries as we go on. So now the libraries are uploaded. Now next we will upload the data files. The data files are available in two files like I told you before. One is the training data file, is a CSV file, and one is the test data file. The training data file and the test data file can be seen here. So this is the test data file. Both the files contain the same number of columns of information. So you can see that it has got invoice number, stock code, description, quantity, invoice date. unit price, customer ID, and country. So this is the information available. We will utilize this information and see how we can make the clustering solution. So let's upload the data. So we are uploading the data into two data frames. One is df train for the training data set and df test for the test data set. You can see that the training data has got your 5.1 million 5.1 million records, and there are some 27,000 records in the test data set. This is not 5.1 million, this is 514,000 records, and both have got 8 number of columns. So we can check the columns what we have in our data set. So we have invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. So let's see the first 20 records. We have already seen the data, but in the training set, let's see the first 20 records. So you can see here, the invoice number is there, but there are some, you will notice there are some uh, special cases which we will treat. So then there is stock code. Stock code basically is the item ID. Then there's a description of the item like child's breakfast set, circus parade, etc. How many quantities were purchased, what was the invoice date on which the purchase was made, what was the unit price, and unit price into quantity will make the value of this particular purchase. The customer ID is assigned and the country where this transaction took place is provided. So we don't require all of this data for the RFM analysis. We basically require the value of the transaction, that is quantity into unit price. What was the monetary value of the transaction? Then we will require the invoice date because this will tell us when was the last purchase made. When the last purchase was made, that is the most recent purchase. So that will give the value of frequency. Then when we sum up the number of purchases by customer ID, we will know how many purchases the customer is making. That will give the frequency value. So before we can proceed with this data, we need to pre-process it because you understand that this data by itself cannot be utilized for RFM analysis. So this will be the case in most machine learning problems where the raw data, what you get may not be directly applicable for the problem that we have in our hands. So first what we do is that we will try to figure out how many duplicates we have in our data set. So let us run this. You notice here there are some 4,754 number of duplicates. So this is much small as compared to 500,000 data records that we have. So we can drop the duplicates. So we will drop the duplicates and we will keep only the first of the occurrence of the duplicate records. So after we drop the duplicates, we are left with 510,000 records in the training data set. Next, we try to find out what are the unique type of invoices that we have. So let us see whether there is any uniqueness in the invoices. So when we analyze the first character of the invoice, we see that the first character can be either C5 or C or A. Now I have some knowledge of this data. So here, when the invoice number begins with a number, it basically means it's a normal invoice. If it is beginning with a C, it means that it's a cancelled invoice. And if it is beginning with a A, it means it's an adjusted invoice. Now, this information normally the domain experts will give you when you're solving any machine learning problems. It will not have to be deciphered or guessed in the most circumstances. So what we will do is we will remove the records which are for the cancelled invoices and for the adjusted invoices because they do not contribute to our analysis, that is the RFM analysis. So let us do some small adjustments. We are replacing the number 5 with an N so that we can understand that these are normal invoices. The invoice number as such is not important for us because we are not bothered about the invoice number. We are bothered about the invoice date. So now when we check the invoices, we find that we have 501,000 records of normal invoices and very small number of cancelled invoices and adjusted invoices. So what we will do is that we will only retain these normal invoices in our data set and we will throw away these this small piece of data. So when after doing that, we are left with now 501,293 records in our data set, in a training data set. Next, we also check whether there are any invoices which have a negative quantity. These are not wrong data. Negative quantity, this particular store has utilized when they return some goods which were purchased and the goods had to be returned for whatever reasons. So the quantity entered was negative in those cases. So we don't require this data. So let's find out how many such data we have. We have 1,287 such records. So we will drop those records as well. Lastly, we find that the stock code, the items, there are normally for the items which are sold by the store, but there are some stock codes which are utilized for special purposes, like some amount is spent on postage or other bank charges, etc. So we will remove these records as well. So we will mark these records where such stock codes exist with a literal, and then we will take out the records which we do not have any of these as the stock code. So this is a small piece of Python programming where if we find that the stock code contains any of these, we attach a literal called remove, otherwise we attach a literal called keep. And once we have done this, we will take out the records where only the stock code is keep. So let's do this. So majority of the records are in the keep set and very few records in the remove set. So we remove the records. Now we are left with 497,806 number of records. Next, we will create a column which is known as, which we will call the invoice weekday, on which day of the week the transaction has taken place. We can take it out from the date of the invoice, and using the function day of week, we can determine the weekday. This is just an exercise, but this again will not contribute to our RFM analysis. This is important for us because we want to find out the monetary value of the transaction. So that monetary value is nothing but the quantity of the quantity in the invoice multiplied by the unit price at which the item was charged. So this data is very important for us. So we get this data. We store it in a different column, which is called total amount. It could be named anything else also. So these are all the steps what we performed from here to pre-process the data so that we can get it in the format. Now we will require all these steps once again. So instead of writing all these steps one by one in each case, we create a function out of it. This function does basically what we have just discussed. All the steps have been put into one function. So if we make a call to this function, all the data will get pre-processed and we will get the data frame like we want it. So the input to this function is the data frame. That will be the raw data what we have, and it will return a data frame from this function, which will be the data frame what we actually require. So we will create this function, and then we will use this function on the data frame which we got from the raw data, and we will create a data frame called tf train to use, which will contain the data that we require. So once we do that, you notice that we originally had 514,000 records, and after processing them, we are now left with 497,806 number of records in 10 columns. We created two more columns. We had 8 originally, and we created two more columns. Now from this data what we have, that is the resultant data what we have, we find out where we have some missing data. So we notice that there is missing data in description. There are 548 records which do not have a description. And also there are some 125,000 records where there is no customer ID. Now this is a concern, but let us see how to deal with that. Now we have to find out the most recent invoice that the customer has made a purchase with. For that, what we will do is we will make a reference date. we will find out the last invoice date that the data set contains. So based on that last invoice date, we will find a relative date, that is how many days have passed since the last transaction was made by the customer. So we just keep it for the moment. Right now in our data set, we notice that the last invoice which is there in our data set was on 9th of December 2011. So right now we keep it. Now we get on to the main step where we create the data what is required for our clustering exercise. So we know that we require three values. We require the value of recency, frequency, and monetary value. So the monetary value we can easily get from the total amount that we have calculated. So if we sum up the total amount based on the customer, then we will get the total monetary value against each customer. And for the recency, what we do is that we find out the invoice date, which is the last invoice date for a customer. That is the most recent purchase what the customer has made. So once we get this data frame, on this data frame, we will do some more, that we will find out the date of the last invoice date, that is the most recent purchase, and we will take the last invoice date that we computed here. This is the same thing here. We will, from this last invoice date in the data set, we will subtract the most recent purchase. That will give us a number of days since the last purchase was made. So our reference date is the last date on which invoice was raised in our data set. So this way we will get all the three values that we are looking for. So let us run this and check what we get. So notice here that we got the customer ID, the frequency, this customer, how frequently he has made a purchase, what is the total monetary value of the purchases that he has made, and how recently he has made a purchase. So this customer 1, 2, 3, 4, 6, he has made only one purchase, but the purchase is of a very high value of 77,183.60 pounds. This is all data is from UK. And this purchase was made some 325 days back. Whereas this customer is making 171 purchases in the period that we have data for, though the total value of the purchase is 4,091. And he has made a purchase just 2 days back. So you can see that there is certain characteristics of the customers coming out. So if we can put together these characteristics of the customers, then we can get all the customers who are falling into some groups. Like we will have some customers who purchase very less, but they purchase very high values. Whereas we have some customers who purchase very frequently, but their value of purchase is very low. If a customer has not come to our shop for very long time, then that means this customer requires to be followed up with or contacted and find out why this customer has not come back. Is he unhappy or whatever? So there are different actions which has to be performed for different sets of customer. And that is the reason why we are trying to cluster the customers. Anyway, what we have right now is the data that we require for clustering. That is the value of recency, frequency, and monetary value. This is recency, frequency, and monetary value. So this transformation that we did, we will put it into a function so that we don't have to do all the steps one by one. We can just call the function. This function again takes the data frame and returns the data frame. That is the data frame containing the recency, frequency, monetary value in a table. So we run this and then we apply this function on our data. So now we have both the training data in the form that we want. One more thing to notice is that the three values that we have, that is for recency, frequency, and monetary value, the ranges of the values is very different. The recency values, it can be as low as 2, but it can be at maximum about 300, 400. Whereas the frequency value can also be very small value, and compared to that, the monetary value of the purchase of the customers is very high. Now, this can make a problem because when we try to cluster, if the data is of different scales, the data which has got a higher range, that will try to bias the algorithm towards itself. So what we do is that we scale the data. The scaling the data basically means that we will try to bring all the data in a similar range. There are two mechanisms for this. One is called normalization and one is called standardization. So we will use the standard scaler. Standard scaler basically takes the value, subtracts the mean from it, and divides it by the standard deviation. So it always gives a value generally between -3 and +3. Uh, we know this standard scaler basically follows the normal distribution curve. So we know that 99.9% data lies within three standard deviations. So we should get a value between -3 and +3. It will be a very, very, very rare case that we will get a value which is outside this particular range. So now let us apply the standard scaler on this training data and then notice what our data looks like. So you see here now, the data has been scaled and we have the data, which is all the columns are in a similar range right now. So this is very odd record because this is a very high value, but normally all the values will be between -3 and +3. So once we have this data with us, now we can try our mechanism to make the machine cluster this data so that we have all the customers in different clusters. The algorithm what we will apply for clustering is k-means algorithm. So this k-means basically means that k is a value which will say how many clusters we want to make. And we will use the means. The means will form the centroids around the data points and around, so if we say make 3 clusters, it will make 3 centroids and we'll try to group the data in those 3 centroids. Now, what we do is that we need to first figure out how many clusters that we need to make from the data that we have. This is not a very easy decision, but nevertheless, we have scientific mechanism to do this. One mechanism which we have is known as the elbow mechanism. So if we try, what we are doing is basically we are trying different values of clusters. That we are trying different values for k. So we have tried from 1 to up to 14. So if we make a cluster, one cluster, then it says that the inertia will be very high. If the inertia is very high, it will not make a very good segmentation. So basically what we utilize this is for, we see that where is the loss becoming lesser and lesser. So we notice here that the loss is, here it is more or less stabilizing here, where around this point, the graph is becoming more and more flat. So in this, from this, we can decide that we need 12 clusters for this particular data. So if you make 12 clusters, then let us see how it looks like. So it has made 12 clusters. Basically, these are the centers of the clusters. Every centroid has got 3 coordinates. This is the coordinates are basically recency, frequency, and monetary value. So we have got 12 number of such centroids. So around these 12 centroids, our k-means clustering mechanism will try to fit the data. So on the customer data that we have, training data that we have, we can assign the label so that we know which customer belongs to which cluster. So this is what is being done, and we save this data that we can utilize later on. Now let us try to visualize what we have just done. So if we try to visualize this, you notice that the data of the customers that we have had has now been clustered into different clusters. So different colors means different clusters. So the similar customers have been put in each cluster. So there are 12 such clusters that you can make out from here. So like I told you, once we have the clusters, now we recorded the clusters, the cluster number against each customer here, and we put it in a column called segment. So once we have this data, then we can create a supervised learning model based on that, where we can train the machine to utilize that information for cluster for assigning a segment to any new data that comes in. So here we are making a supervised learning model. It's a classifier, and then we are trying to check whether how well it works. We will discuss this classification in a separate video. So anyway, you can go through this, but this is not the topic of this discussion. So that's why I'm skipping this and moving forward a little bit quickly. Now, here we have the test data. The test data, we transform the test data using the function that we created, and we got the data in this particular format. So we know that the test data, the test data was in raw format, and we transformed it and got this data. On this data, now we can try to make predictions for the test data. So when we make predictions for the test data, it will assign the clusters to each of the data points, and we can visualize our cluster in this manner. So here there are 12 clusters made of the test data. So you notice that we have started with the raw information, and then we have now data which tells us the customers which have been clustered into 12 different clusters, and each different cluster we can find out further what the cluster characteristics are, and we can treat those customers in a different manner. So that brings us to the end of the demonstration of a clustering algorithm which machines can be made to learn. Thank you for listening.